Okay, question number 1. We need to find the critical value, the critical, necessary to form a confidence interval at the level of confidence, 0.82. Or we sometimes write down, instead of this C, see it's the same C, right? We put 0.82. So the critical is, let me see, 0.82. It's a confidence level, which is can be anything between 0.82, all right, or 82%. And the z-criticals are the border of this confidence level, which is going to be negative z-critical and positive z-critical. Now, because the tails it create, they are identical area, same area, therefore, let me get this one. Therefore, a z-score also going to be the same. So I can take negative z-score, z-critical, and flip the sign to positive. I will get the positive z-critical. So let's see how we're going to find out. First of all, the confidence level is 0.82. That means it's a confidence level, 82%, which means I'm going to look in the table, not as a z-score on the side, but in the body, 0.82. So if this is yellow area, 0.82, then for the two tails, it's going to be 1 minus 0.82. It's going to be 0.18, right? For two tails. Now for 1, because we need 1, it's going to be, because our table shows to the left. Now if I take both of them and we have n to the left and to the right, which one to look, right? So we take 0.18 divided by 2, we get 0.09. Okay, 0.09, so this is 9%, and we're going to find in the our table. So since we know that here it is, our bell-shaped, the mean is going to be equal right here, z-score is equal 0, that matches to our mean, and it's separated from negative 0% to positive 50%, and the second area is from 50% to 100%. Okay, since we have 0.09, which is 9%, it's gonna be in this area, right? Low at the 50%, because 0.5, which means our z-score is gonna be negative, and it's gonna show to the left. So I'm going to find this area, this area, which is 0.09, this one. All right, 0.09. And now one thing you need to know, it doesn't necessarily have to be 0.09. It can be approximate. Okay, it can be approximate 0.09, just like I found here. It's 0.09. Where is it? 01. 0.0901. So it's quite, if you round it up, 0.09. So, and it's coming to the left, it's going to be negative 1.3. And going up, it's going to be 0.04. So the z-critical is going to be at a negative 1.34, and because in formulas we use positive z-critical, so our z-critical for 0.82, it's going to be positive 1.34. Okay, question number 2. So the same thing, we need to find z-critical for the confidence level of 0.91. So what we have to do again, to subtract 1 from 0.91, subtract from 1, it's going to be 0.09, right? And we divide by half because we need to take 1/10. Divide by half, it's equal 0.045. So it's going to be, this is our 91%. These two together will be 9%, two tails. This tail and this tail is going to be 9%, and one is going to be 4.5%. Yes? This one, 4.5% or 0.045. So I need to look in the table, look up for 0.045. Let me see what I'm going to find approximate value. And again, keep in mind 0.045, we are looking in the negative z-score area because 4.5% is less than 50%. Okay? And it is going to be 0.294, 35944, 45. I found 0.4446. Okay, it's close enough. 0.0446, which is approximately 0.045. So if you come here, it's going to be negative 1.7. When it's come here, it's going to be 0.0. Okay, let me build it better way, because 0, 0 is at the beginning of the table. Okay, like this. And it's going to be negative 1.7. So from here, Z critical for the 0.91 confidence level is going to be 1.70 or 1.7. Okay, question number 3. Find margin of error. Margin of error when its confidence level is given 0.9. What else is given? Sigma is equal 2.1 and n is equal 64. So word problem we usually start solving backwards. So we need to, first of all, we need to find out what's the formula for E, margin of error. Formula for margin error is Z critical sigma over square root of n. So let's see what we have. Do we have n? Yes, 64. Do we have sigma? Yes, 2.1. All we need to find Z critical, right? Let's find it. So our C is equal 0.9. Here is 0.9. This is 0.9, 90%, which means these two areas, this and this, is going to be 1 minus 0.9, which is equal 0.1. We divide by 2, 0.05. 0.05. Now let's go find 0.05 in the table of negative z-score. 0.10. So 0.0548. Let me see. Okay, I found it's between, let me show you. It's between 0.0505 and between 0.495. Okay, so we have to look right in the middle. So this is going to 0.04. This is going to 0.05, so this one will be 0.045, right? And this is coming horizontally. We are getting to negative, let me see, what was that? 1.6, negative 1.6. Therefore, Z critical is going to be 1.645, yes? Let's solve margin of error. Margin of error is 1.645 times, what do we have there? Sigma 2.1 and square root of 64, which is going to be equal 1.645. Here is 2.1, square root of 64 is 8. So now let's solve it. So I have 2.1 divided by 8. I'm getting 0.2625 and multiplying by 1.645. And the answer I get 0.43. So 0.43 is margin of error. Question number 4 free, okay, it's asking for 3 decimals, so it's going to be approximately 432. Question number 4. Now we need to find confidence interval. Confidence interval. When what we are given, confidence level is 0.98. X bar is equal 15.8, sigma equal 2.0, and n is equal 80. Okay, so how the real quick confidence interval is equal X bar and then minus error and X bar plus error, and that's what's going to be our confidence interval, these 2 points. So X bar, are we given? Yes. If somebody want to learn what means confidence interval, please go to video lecture. So confidence at the X bar we have 15.8. Now all we need to find is margin of error. So we know that our margin of error is equal Z critical sigma over square root of n. We have n, we have sigma, all we need to find out Z critical, and we know how to find out. 1 minus 0.98 is equal 0.02. And then 0.02 we divide by 2, we get 0.01, right? Going to the table, 0.01 is 1%, so it's definitely going to be negative z-score. 0.01, negative z-score area we need to find. 0.01, let me see. Oh, I got 0.0099. Okay, so z-score for z critical for 0.98 is equal negative 2.33, or we can take middle also. Okay, we have 0.0102 and I have 0.099. So looks like it's going to fall right in the middle. So if this is, what is this 2? We have 0.02 and 0.03, which means this will be 0.025. And coming here, this is negative 2.3. which means this one will be 2.242, oh, 2.325. That's what come out. Okay, 2.325, which means this score gonna be the critical. It's gonna be 2.325. Okay, let's plug in the margin of error is equal to 2.325 times sigma is 2, n is 80, square root of 80. Let's find out square root of 80. It's gonna be 80, where is my square root? 8.94. 8.944. Okay, so from here, 2 divided by 8.944, it's getting 0.2236, and multiplying by 2.325, and we are getting 0.52. 0.52. Okay, let me combine. Okay, 0.52. So once we have margin of error, the confidence interval is going to be x minus error, right? And that's a confidence interval for population mean. So mu is greater than x bar minus error and less than x bar plus error. This is going to be our formula. So which means we have we have x bar 15.8 minus error, which is how much? 0.52. So x bar minus error, and then x bar plus error, 15.8 plus 0.52. Okay, so if we do minus, it's gonna be 8. 7 minus 5 is 2, and here is 15.28. And when we add, it's gonna be 16.32. So since they want only one decimal, so this one is going to be approximately 15.3, and this one is going to be 16.3, which means the at how many percent? 98% confidence interval. The interval for mu is between 15.3 and 16.3. Question number 5. What do you have? Use the confidence interval to find margin of error and the sample mean. Margin of error and the sample mean. So, what do we need to do in this case? So we are given margin in the confidence interval, which is given 0.062 and 0.240. So we need to find margin of error and sample of error. So first let's find margin of error. So when we find margin of error from the interval, so it's gonna be equal. So it's gonna be equal. You take one end of the interval, 0.24, and subtract the other end, which is 0.062, and divide by 2. So 0.24 minus 0.062 is equal 0.178 over 2. And that's going to be equal 0.089. Okay. And to find the sample mean, x bar, what we are going to do, we are going to take the lower end of this confidence interval, which is going to be 0.062, add our margin of error, which is going to be 0.089, and that is equal 0.089 plus 0.062, and we are getting 0.151. And that is our sample mean. Okay? Question number 6. So here we need to solve the problem. Okay? We have problem here. So we are given the sample mean and population standard deviation. Use the information to construct 90% and 95% confidence interval. So confidence interval 90% and 95% for the population mean. Okay. So what we are given, random sample of 50 home theater systems, which is n is equal 50, has a mean of $149, and standard deviation is $1960. So we need to construct confidence interval. So confidence interval to unknown mu for in that interval, mu is greater than x bar minus error, less than x bar plus error. Are we given x bar? Yes, x bar is here. What we need to find out? Margin of error. So margin of error is equal z critical sigma over square root of n. Okay, do we have z critical? No, we don't. So z critical, z for 90%, let's find for 90% or 0.9, correct? All right, for 0.9, it's going to be 1 minus 0.9, it's going to be 0.1. And then 0.1 divided by 2 is equal 0.05. So where is my 0.05 in the negative table? 0.05. here it is, between 0.0505 and 0.0495. So it's going to be Z critical is going to be equal, where is it? I found it. Here it is, negative 1.645, which means we're going to use positive 1.645. So from here, margin of error is equal 1.645. Here we have 19.6 divided by square root of, how much is n? N is 50, square root of 50. Okay. Square root of 50 is 7.07. 7.07, and here is 19.6. So this is gonna be, so 19.6 divided by 7.07, that's gonna be 2.77. Let me see, 1.645 times 2.77. So 77, I multiply 1.645, and that is equal 4.56. Okay, now we need to find the interval where mu greater than x bar minus error less than x bar plus error. Okay, how much is my x bar? X bar is 149. So minus error, let me move this. $149 minus 4.56. 149 minus 4.56. Okay, calculator is not for me. Every time I punch calculator, I get weird numbers. So I'm going to do myself. 4.56. So 149 minus 4 is 145. 145 minus 0.5, it's going to be 144.5. And 144.5 minus 0.06 is going to be 144.44. Now x bar plus error, it's going to be 149 plus 4.56, and that will be 153 and 56. And this is going to be our confidence interval. Mu is greater than 144.44 and less than 153.56. Okay? Next, the same way we are going to work out for 95%. Yes? Let me do real quick for 95%. So calculation, everything stays the same, it just C critical is going to be different. So 95%, this is for 95%. Z critical for 95%, 0.95, is going to be, first of all, 1 minus 0.95 is equal 0.05. And then 0.05 we divide by 2, we get 0.025. So we need to find in the table 0.025, and it's going to be negative table, 0.02, 02, where is my 25? 8762, precisely 0.025, it's negative 1.96. Okay, negative 1.96. So from here, margin of error is going to be 1.96 times 19.6 over square root of 50. So it's going to be same result. We are getting 1.96 times the same 2.77. Okay, same 2.77. Let me multiply. So that's going to be 5.43. 5.43. So from here, mu greater than x bar minus error, less than x bar plus error. We have x bar, which is, x bar minus error is equal 149 minus 5.43, and x bar plus error is going to be 149 plus 5.43. Okay, how much is going to be? 149 minus 5.43. It's going to be 143.57, and 149 plus 5.43, and that's equal 154.43, which means the interval is going to be 143.57 comma 154.43. So our with a 90% confidence interval, our mean is located within 90% confidence interval, and those are values of this 90% confidence interval. Okay, number 7. There is one more question. Let's see. Oh yeah, it's practically we are reading what it was saying. With 90% confidence, we can say the population mean lays between 143.57 and 154.93. All right, moving to question number 7. It says confidence interval C is equal 0.98. Sigma is equal 9.7, and margin of error is equal 1. All right. So let's see what we're gonna do. So we need to find now the minimum sample size here. We need to find n sample size. Okay. All right, let's see how we're gonna solve it. So the formula for minimum sample size is n is equal Z critical sigma over E. And all that is squared. All right? Let's solve it. So we need Z critical, correct? We have sigma, which is 9.7. We have a margin of error, which is 1. All we need to find out is Z critical. So we need to find out Z critical, so we can find the minimum sample size, N. So C, which is confidence level, is equal 0.92, right? Real quick. This is 0.92. So, which means on these tails will be left together, right? Together will be left 1 minus 0.98, which is 0.02, which means for each one will be divided by 2, 0.01. Since the areas are the same, that means these Z criticals are going to be the same also, no, same by absolute value, the same, which is here will be negative Z critical, here will be positive Z critical. So if we find negative Z critical through this left tail, because area, the table shows left, then we can flip the sign and get positive Z critical also. So 0.01. Let's find, so we are looking for Z critical for 0.01. Let me see, where is it going to be? I'm looking in the negative area, 0.01. The main problem is not to get confused, take two zeros. It's happening very often. I don't know why. The closest one I found is 0.0099. It's where is it? Okay, right here is 0.0099. So if you round it up, it approximately will be 0.01, right? And it coming here, it's going to be negative 2.3, going up, going to be 3. So negative 2.33, 0.03. So is equal negative 2.33, which means we are going to use positive one, right? So let's apply for N now. What do we have? Positive 2.33 times sigma squared, sigma 9.7, and divided by 1, and all this squared. So practically we are going to take 2.33 times 9.7, okay, squared. So that's gonna be 2.33 times 9.7, that is equal 22.6 squared. So let's see, and that's going to be 510.8, which approximately it's going to be 5, which means rounding till 511. The thing is with sample size, since it is going to be minimum sample size, minimum, you can be, that means you can take more size, the greater size, but not less. Therefore, even if you would have 510.01, you would round it up till 511. Okay, this is not a mathematical rounding, it's just 510 is minimum. So you want nothing will hurt to get next higher. So it's going to be 511. All right, that's how we work. Because it's you need more than 510 by 0.1, right? You can't take 0.1 of the person, but you can take the whole person, which will bring us to 511. That's my point. Okay, question number 8. Let's see what we have here. It's going to be similar, minimum sample size. Minimum sample size for the given confidence level, which is 0.9. Given sigma, standard deviation of the population, is equal 9.8. And margin of error is equal to. So we need to find n. And that is equal z critical sigma over margin of error squared. Yes? Let me, okay. All right. So we have sigma, we have error, all we need to find out z critical. Okay. For z critical, we need to find out, first of all, C confidence level is 0.9, which means for tail, it's going to be 1 minus 0.9, which is going to be 0.01. Let me see, do we have here 0.9? No, 0.98. So it's going to be 0.1. Okay, I'm sorry. It's going to be 0.1. Okay, and then we need to divide 0.1 by 2 because 0.1 is for two tails, right? This and this, it's 0.1. And if we divide by 2, we get 0.05. Then we need to go find 0.05. Let me see how much it's going to be, 0.05. The closest one I am looking is, it's going to be, okay, it's going to be 0.05. It's going to be between 0. See, I put 0.05. Yeah, it's going to be between 0.0505 and between 0.495, which is equal distances from each other, 495, which means our choice, it's going to be in the middle, 0.05. And in the middle, it's going to be, this is this one 0.04, this one 0.05, this is going to be 0.045. Okay, and horizontally coming negative 1.6. So Z critical for 0.05 is negative 1.645. Okay, now let's plug to formula. N is equal 1.645. Remember, we are using positive one, times sigma 9.8 divided by margin of error, which is 2, and all this is squared. Let me grab calculator because it will take me time to multiply square and divide and square. So what do we have? 1.645 times 9.8, that's going to be 16.12. 16.12 over 2 squared. So let's divide by 2. It's going to be 8.06. And once we square, it's going to be 64 and something, yeah? We'll find out. 64.97. So clearly it's coming to 65 as a minimum. All right, we are good. Question number 9. Question number 9. Now here we need to find T critical. T critical for the confidence level C is equal 0.99 and sample size N is equal 22. Now for T critical, I will highly recommend watch the lecture that's going to be in chapter 6.2, I believe. Okay, all I can say, T critical we can use when we have sample size less than 30 or standard deviation for the population is not given. See, if you look at the all these cases here, we have standard deviation. See, standard deviation is given. Looking here, standard, this is for sample size, but here also if I look, standard deviation is given here. So at the second, standard deviation for the population is not given, and it doesn't matter n is less than 30 or not. It can be n is greater than 30, but as long as standard can be less, let's say 22. But if I would have sigma given, then I would use z-score instead of t-score. One more time, let me repeat, so make sure you are not confused. If my standard deviation is given, then sample size condition going away. So if the standard deviation of the population is given, then we are using z critical, period. But if standard deviation for the population is not given, then we are going to use t-score. And obviously n is going to be, as a rule, it's going to be less than 30 when standard deviation is not given. Okay, that's the difference. Otherwise, t-score we are using also for normal distribution, just like z-score. It's just the t-score represents z-score for the case when either standard deviation for the population does not exist, please make a note, or table is less than 30. Okay? So, for t-score, we are going to open the table for t-score. I will see if I can, I don't think I can put in the comment, attach the table. No, but you have it here. I see it's giving to you t-score table. I'm looking on your MyMathLab. Therefore, to find out t-score, you're gonna need on the left side, it's gonna be degree of freedom. I'll tell you in a minute. Degree of freedom. And horizontally, you will have either confidence level C, let's say 0.98, or the one tail, alpha for one tail, and alpha for two tails. Two tail is going to be 0.02 because 1 minus 0.98, you get 0.02, and one tail will be 0.01, half of 0.02, right? So pick one of them, whichever is given, and intersection will give you your t-score. Okay, now degree of freedom, how to find degree of freedom? Degree of freedom is equal n minus 1, which means in our case, it's going to be degree of freedom will be equal 22 minus 1. It's going to be 21. Please, please, please watch the video so you can understand. Degree of freedom is nothing else but when you have something that only portion of it is working. Let's say part of car. Some part of car can move only up and down, the other one only right and left, or a robot is programmed the way it can raise only hand, the other hand can only keep down, and robot can only turn to the right or to the left. Those are its degree of freedom. You set any part or any object, set the freedom up to degree. That's what it is. Okay, so what do we have? We have 0.99 confidence level. N is equal 22. So my degree of freedom is going to be 21. Since my C is given 0.99, I'm going to where 0.99 is, and 21. And it is gonna be 2.831. So T critical from the table is gonna be 2.831. How? Let me write down so you would know what to look for in the table. Although I explained, but it never hurt to write down one more time. Not a big deal. I looked up for C, which is 0.99, here it is, and looked up for degree of freedom, which is 21, and this intersection gave me 2.831. Okay? Next one, question number 10. What do we have here? We have question number 10. We have confidence level 0.95, and we have sample size is equal 14. So 0.95, I already have it. I can look it up here, 0.95, but I need degree of freedom, which is going to be 14 minus 1, which is equal 13. Let's say this is my 13, and find intercept. So let me see, 95 and 13. This is 13, 95. It's going to be 2.160. T critical is going to be 2.160. Okay, moving to question number 11. Construct indicated confidence interval where C is given, confidence level 0.9. What else is given? X bar is given 12.8. Remember what I said, T critical, Z score, it's same meaning, same everything. It just T score we use for less sample size, or sample size that is less than 30, because 30 is a cornerstone, and the standard deviation of the population is not known. In this case, it's given standard deviation of the sample, and we were talking about population. Standard deviation of the population is 2.0, and sample size is equal 7. Now, how we are going to work with it? So first of all, we know that our we need to find the population mean using T distribution. So confidence interval of mean for using the T distribution is going to be greater than X bar minus error, less than x bar plus error. So it's exactly same formula what we did. We have x bar, and we same way we need to find margin of error. For margin of error, in the case of t-score, we are going to use t critical and s, meaning sample standard deviation, square root of n. All right, s we have, n we have. We need to find t critical. How much is going to be t critical? Let's see, I'm going to look for 0.9 here and come down, n is 7, that means I'm looking for 6. Let's see, let's open and see. Zero 0.9 and 6. 0.9 coming here, 6. It's going to be 1.943. 1.943. Okay, 1.943. Now we can plug and find out how much will be our margin of error. It is gonna be margin of error 1.943. Here we have S 2.0 divided by square root of 7. Okay, let's see, square root of 7. Let me open calculator. Square root of 7 is 2.65. Okay, 2.6446. So 1.943 times 2 divided by 2.646. All right, let's work on it. It's gonna be 1.943 times 2, okay, 3.886, and divided 2.646. So dividing by 2.646, and that's going to be 1.469, or if I round it up, looks like they require to 1 decimal. Okay, since my x bar also 1 decimal, it's going to be 1.5. So from here, x bar minus error is going to be 12.8 minus 1.5. And that is going to be 12.8 minus 1.5, it's going to be 11.3. And then x bar plus error, it's going to be 12.8 plus 1.5. It's going to be 8 plus 5 is 13. It's 3 and 4. And here is 14.3. So confidence interval, we can say with 90% confidence, 0.9, that the mean is located somewhere between 11.3 and 14.3 for T distribution. Okay, question number 12. In a random sample of 19 people, so n is equal 19, the mean commute time to work was 30.1 minute. So the average was, x bar was 30.1. Why I don't put mu, I put x bar? Because it says in random sample of 19 people. This 30.1 is about 19 people. 1 minute, the 30.1 minutes average time to commute. And the standard deviation That's going to be standard deviation for these 19 people, but because it's sample, we're going to use S is equal 7.3 minutes. Okay, assume the population is normally distributed. We can use t-score or z-score only when distribution is normal. And using t-distribution, we have no other choice. Standard deviation sigma is missing, and sample size on the top of that is less than 30. So using t-distribution, construct 90% confidence interval. It's 90%, which we put 0.9, obviously. Interval for the population mu. So we need to find mu, that is question mark, where mu we know is greater x bar minus error, less than x bar plus error. Okay, so x bar is given, all we need to find out our error. Error is equal T critical S over square root of n. Okay, T critical. So we have 0.9, this is C, 0.9 right here. And at the degree of freedom, since it's 19, degree of freedom is going to be 18, minus 1. 18. Let me go open it. So 0.9 and 18. Is going to be 1.729. T critical is going to be 1.729. Okay? So, $1.729. Okay, now we need to find margin of error, which is going to be 1.729 times S is equal, 1.729 times S is equal 7.3 divided by square root of 19, right? Okay. So square root of 19 is equal let me write down 1.729 times 7.3 divided by 4.359. Okay, that is equal 1.729 times 7.3 and divided by 4.359. That is equal 2.895, which is approximately going to be 2.9 because they are requiring 1 decimal, right? Okay. So from here, 2.9, from here, x bar minus mu, it's going to be x bar is 30.1 minus 2.9, and x bar plus error, it's going to be equal 30.1 plus 2.9. So first one, minus 30.1 minus 2.9. So 11 minus 9 is 2. Here we have 9. 9 minus 2 is 7. And instead of 3, we have left 2. 27.2. Okay, now if we add, 1 plus 9 is 10. And then 0 plus 2 is 2. And 1 will be free, rolling over, right? From 1 plus 9. 1 rolls over. And we get 33. So our average of the population is going to be between 27.2 and 33.0. 0, somewhere in the middle. Now, and margin of error we already solved is 2.9. So what can we say? With 95%, with 90% confidence, it can be said that the population mean commute time is between the bounds of the confidence interval, or meaning in between 27.2 minutes and 33 minutes. Okay, moving to question number 13, which is moving to chapter 7.1. We're going to talk about hypothesis test. Hypothesis test is nothing else but claim, and you are testing if the claim is it's going to be rejected, or we don't say in statistical language, we don't say accepted, we say fail to reject, which means indirectly that means accepted. Okay? All right. So, for the statement below, write the claim as a mathematical statement. State the null and alternative hypothesis. So the claim is going to be true or false, right? This claim is going to be either true or false. True, we always accept as a null hypothesis. We say H null. And alternative is going to be H alternative. Like this. So now we always take as a truth, and then we check it. It's like innocent until it's proven otherwise. Something like that. So state the null and alternative hypothesis and identify which represent the claim. Okay, the laptop manufacturer claim that the mean life of the battery for the certain model of laptop is more than 9 hours. So mean for some batteries is more than 9 hours. So we need to understand one thing. So more than 9 hours, every equal sign, if there would be at least 9 hours, then I would write down mu greater equal 9, right? If it would say at most 9 hours, then I would write down less equal 9 hours. Now, every time where equal sign is present, it goes to null hypothesis. In our case, the equal sign is not present because it says more than 9. Therefore, this mu is going to alternative greater than, greater than 9 hours. Please, please, please go watch the video lecture so you can understand what I'm talking about. So in this case, claim is this one, right? So what will be left for null? It's going to be left less equal 9, complement. This null and alternative are complement to each other. If one is greater than the other one, less equal. Let me write down, if one is greater, then the other one will be less equal. If one is less, the other one is going to be greater equal. If one is greater equal, the other one is going to be less. If the other one is less equal, the other its alternative will be greater than. Yes? Okay, so let me clean this, not to have a mess. Okay, so what do we need to do? We need to put the claim. Claim is going to be mu is greater than 9. And accordingly, the correct null and alternative hypothesis is going to be this. Okay, so, and the claim is our alternative hypothesis. Moving to number 14. So we need to write down the statement again. So what do we have? An amusement park claims that the mean daily attendance of the park is 21,000 people. When it says is, it doesn't say at least, it doesn't say at more, it doesn't say less than, it doesn't say more than, it says is, which means mu is 21,000. So if it's equal, so we remember what I said, equal sign always goes to null hypothesis, always, which means claim is going to be null hypothesis, mu is equal 21,000. Now curious, what is going to be alternative complement? If it's equal, then it's going to be not equal. And that will be our null and alternative hypothesis. Okay? And the claim is going to be which one? This one. Because our mu is 21,000. That's the claim. Okay, question number 15. I think I can write down number 15 on this side. So we are given null hypothesis is mu, that is equal 138. Okay. Alternative one, mu is not equal 138. And p-value, I'll tell you in a minute, is equal 0.0137. Okay. So what is p-value? Let me explain a little bit so you can understand. Wait, and we have significance level 0.01. Okay, we have alpha, which is significance level 0.01. Now let me explain what it is. P-value of a hypothesis test is the probability of obtaining a simple statistic with the value of extreme, which this is extreme, right? Tail, because majority average is located here. But this is going to be in the tail p-value. It's going to be our p-value, extreme value. Okay, it's an extreme or more extreme than one determined from the sample data. So significance level 0.01. If p-value is less than alpha or equal to alpha, then we are going to reject null hypothesis, whatever it's going to be. If p-value is greater than alpha, then we fail to reject null hypothesis. Why we are referring to null hypothesis, reject or not reject? because we always start testing with null hypothesis. No matter what is the value of null hypothesis. Now, it doesn't matter if it's claim or not claim. We always start with null hypothesis. Okay? Okay. So, in this case, do you reject or fail to reject null hypothesis at the 0.01 level? No, we fail to reject null hypothesis because in my case, p-value is greater than alpha because I have 0.0137 greater than 0.01. Now, I introduced a little bit into p-value and alpha, but to understand it, you have to watch the video, please. Video lecture, it's going to be 7.2 for this one. Okay? All right. That for significant 0.01. Now, let's take significance level 0.05. Then what's going to happen? My p-value is 0.0137. Alpha is 0.05. Don't need to rewrite twice. Right? This is a B case. Let me mark down case B. And this one, case A. Then what's going to happen? In this case, my p-value is less than 0.alpha, right? Therefore, we reject null hypothesis. Here we have failed to reject. Okay? We are good. Number 16. It's something similar. So, what are we given? We are given for A, alpha is 0.01 and B, for B, alpha is 0.05. I was thinking write down now or after. Alpha equals C equal 0.1. Okay, for all three, p-value is the same for all three, and that is equal 0.0435. 0.0435. For case A, I can say that p-value is greater than alpha, which is 0.0435 is greater than 0.01. When it is greater, look what we have. Fail to reject null hypothesis. Fail to reject null hypothesis. Case B, we have p-value is less than alpha because 0.0435 is less than 0.05. For the case B, we reject null hypothesis, right? Because p-value is less than alpha. Reject null hypothesis. And for the case of C, we have p-value greater than alpha because 0.0435 is greater than 0.1. Okay, I was going with 0.01. Okay, less than. Is less than 0.1, which means we reject null hypothesis. Okay? And the last one, question number 17. What do we have here? Claim the standard deviation of pulse. Oh, okay, original. We need to write down the claim. The standard deviation of pulse rates of adult males is less than 10 beat per minute. So sigma, standard deviation, right? It says less than 10. Okay. Pulse rate. So for random sample of 130 adults and 130 males, the pulse rates have a standard deviation of 9.4. So in the standard case, it's 9.4. So here it's less than 10. Okay, so we need to first express the original claim in symbolic form, which already we have. So sigma is less than 10. We already put it. And B, it says identify the null and alternative hypothesis. If it says less, where is it going? Yes, a null hypothesis or alternative? Of course it's going to alternative because null has equal sign, has to have there, right? So this is null. This is alternative. Since equal sign is missing, then it's gonna be alternative, less than 10. Yes? Okay. Let me write down. Sigma less than 10. So what will be the complement for the null? It's going to be sigma greater equal than 10. And that's all. Thanks for watching. And I'll see you in next video.